The quotient rule is another rule we use in calculus in order to differentiate more complex functions. You've done the chain rule where it's a function inside another function. The product rule is two functions multiplying, and the quotient rule is a function divided by another function. Now you can escape using the quotient rule, but it's much easier to use this expression. But we have to be careful because it's very specific about what you subtract and what remains the same and what is the derivative and what multiplies. So I can explain the whole thing through an example. Now, let's say you have this y equals to x squared minus 3 divided by 3x minus x squared. I want to define this y as a function over another function. So I want to do a u of x divided by v of x, given that v of x is not equal to 0. So I can do that quite easily. You can spot that u of x can be x squared minus 3 and v of x can be 3x minus x squared. So far with all the rules that we've done, you're noticing that we're always doing some sort of substitution. And obviously you can use different letters if you want to. The next step, hopefully you can guess by now, is to differentiate each. So I have u prime is 2 of x and v prime is 3 minus 2x. So now that I have it, I can actually use the derivative rule here for the quotient rule. So dy by dx will be this whole mess. Now what does it actually mean? Well, it just tells me that I need to take the original v and multiply it by the derivative of u, and take away from it the original u multiplied by the derivative of v, divide the whole thing by v, the original v squared. Now the reason we're using square brackets is because we don't want to confuse it with too many curved brackets, but it's still the same thing. Basically what it just says is take v of x and then square the whole function. So this is what it will look like. So first we're taking this original v and we're multiplying it by u prime, and then we're taking away the original u multiplied by v prime. And then we're dividing the whole thing by v of x, and we're squaring it. So be careful what you minus. This is what I mean. Like if you switch the order, it's not going to be correct. You have to put in the correct order of the original v times u prime, not start with u and multiply with v prime. You can also use this kind of cross diagram if you want to. So you define u and v, and then u prime and v prime, and then do this kind of cross arrow thingy. That might help. So once you have it in this format, you just then expand and simplify. You need to make sure that you expand properly. So you have to go here. You then have like a double bracket expansion situation here. Don't forget your basic algebra. Expand, and be careful, this whole thing, whatever answer you get here is being minus. So you need to simplify it accordingly. So for example, if this side ends up being, let's say it won't be, but let's say it's going to be 2x minus 5, and then you have this minus, so the minus has to go into 2 with the 2x and the negative 5, so you have to be careful with the negative here. So try this on your own, simplify it, and hopefully you're going to get 3x minus 6 plus 9 divided by the denominator squared. Now you might be asking, should you derive the denominator? Not quite, you don't need to, because, should you expand the denominator? You don't have to, because it won't really serve any purpose at the moment if you do. You can leave it just in the factorized form. Even if the question tells you to simplify it, this should be enough. So hopefully the video is clear. It's just a matter of understanding what the formula is and knowing what values to put in the correct order. Now I'm going to spend a few minutes just explaining how you can use the product rule and how the product rule can help us arrive at this quotient rule. If you don't want to see that part, you can skip. So the idea is you can redefine this function using the quotient rule, so the product rule. So I can put this in a bracket, and this is to the power of 1. So I can bring it to the numerator by saying this is 3x minus x squared minus 1. And then I could use the product rule for this and for this. So by using the product rule, you're actually going to end up with the same exact answer here. So it will be quite interesting for you to try it out. So if I generalize it overall, if I use the generalization of the product rule, And if you're much better with algebra and you want to kind of define this as v of x to the power of -1 and use the product rule on these, you can actually arrive with this the rule for the quotient rule. But this is a bit of an advanced level, but it's quite interesting if you want to have a go at it. So you can see how the formulas link, the rule links together. We're not jumping to the quotient rule immediately. It actually came from a previous process. But using it again, it should be quite simple. You just find your substitutions, you differentiate them, and then you follow the rule exactly.